Teaching Objective 19, Year 2, Term 2, Group Discussion and Interaction. To ensure everyone contributes, allocate tasks, consider alternatives and reach agreement. In this Year 2 science class, children are using talk to plan an investigation and predict outcomes. Throughout the sequence, notice how the teacher challenges children to test their scientific understanding. Children cooperate on tasks in groups of different sizes. Use talk to organise and explain their work.
Today we're going to be planning, predicting and exploring what happens to a vehicle when it travels on different surfaces. What did we change last week? That's what we kept the same. What did we change? Connor?
The ramps.
Did we change the ramps? Think about it. Would that have been fair?
The cars.
We changed the cars. Why did we decide then, Connor, to keep the ramps the same? We didn't change the ramps. Why?
Because we wanted to make them the same.
You're getting there. Why would we keep it the same? We're testing the cars. We've kept the surface the same.
We wanted the cars to go the same.
Did we? I think you need to share this for a minute. Talk to your partners for a second and just share your ideas.
Notice how the teacher gauges children's understanding about changing and constant variables and what makes a fair test.
So who can tell me now why they think they kept the ramp the same? Kirby, do you think you could try?
If one was on carpet, then that one might go further than the one which is on something different.
Right. And Ben, what did you think?
If there was like two ramps, one could be slippery, one could have lots of grip and it won't be a fair test.
In groups, the children make predictions and observers note how well they contribute ideas.
Observers in the group are going to be able to check that everybody takes part in the planning. Connor said to me it's very important that everybody takes a turn, gets a turn to give their opinions. If they don't get that turn, you might be missing a wonderful idea. So you need to make sure you include people and you have to think how you're going to do that. Think about different people's ideas, and that's what the observers are going to be trying to see if their group is achieving. Okay. And these are the questions that you are going to be considering in your group. I'm going to leave these up here so you can check. It's like your checklist. You can check you've been through all of these. Observers. You know who you are, the observers in the group. You've got a very important role within this group. Your role is to watch your group and see how they are working together. How is that helping the planning of their investigation? I've got your checklist for you, so you can check if everybody's taking turns when they're speaking. How are they making their suggestions clear? Are they using this because when they're making their predictions?
What will you change? The car. No, the surface. What will you measure? With a meter stick. No, you don't measure a meter stick. No. The distance. How will you measure? When the car stopped. Meter stick. Where the at the front of the ramp. And then makes it to stop and then you measure. Predict what do you think will happen and why? I'm gonna put the car down the ramp and Sam's gonna measure it and he's gonna get the stuff and set it up And Kirby's gonna do... I'm gonna write it down. You're gonna write it down and Chloe's going to... Chloe could set it up.
The teacher asks 2 observers to report on one group's predictions.
They thought the car would go slower on the carpet and the bubble wrap. And all of us thought the car would go further on the lino.
Right, so you think it's going to go further on the lino, but why? Why did they think that?
Because it was smoother.
Because it was smoother. You said it was going to go slower on the carpet. Are we measuring how fast it goes, or what are we actually measuring, did they decide? What did they decide
Well,
we're going to measure?
Kirby said we're not like measuring how like fast it goes, we're measuring how further it goes.
Did they all agree with that?
Yeah.
Did they all have a chance to put their ideas forward?
Yeah.
What about the surface it would go least far on? What did they think?
Some thought it was on the carpet, and some thought it was on the bubble wrap.
Did they give reasons for that?
No.
Didn't they? Nobody gave a reason for why it wouldn't go far on the bubble wrap.
I did. Yeah, Darcy said because on the bubble wrap they're like speed bumps.
That's right. They are a bit like speed bumps, aren't they? So, and what are speed bumps used for?
To slow cars down.
So we're on that slow and fast again. Would that make a difference? Do you think the speed the car is going is going to make a difference to how far it's going to travel?
Yeah.
You think there's going to be a connection there?
Yeah. Because if it goes slow, it might just go slow, then it might stop, so it won't go far. But if it's going fast, it'll go fast and a long way, then it'll just stop.
Having made their predictions, the children work to test their ideas about speed and distance.
71, 72, 73, 74 centimetres. That was not a fair test. Yes, it was. Oh, it was. 102, 103, 105. 40, 41, 55. That was the furthest one.
Our envoys are going to go to a different group to explain to the other group exactly what you did and what you found out.
Envoys from each group share their findings with a new group.
What did you use it on? Sandpaper, bubble wrap, the floor and the lino. No, I mean, what did you do it on to make the car go down to that ramp? The blue car was the best on the sandpaper. Yeah. The green car kept doing, and it kept yeah, and then it turned because then the bubble wrap was turning it. The green one kept going. Yeah, the car goes down the ramp. It'll just go. No, because it's got that bit there, hasn't it? And the line through there. So that's why the bit down there would stop it from going down. It's because of the bubble wrap. The sandpaper was all sticky, so when the car goes down, it went the furthest, so we had to get 2 sandpapers. It was sticky. No, it wasn't. It was like just tarmac. Yeah, it's like tarmac. Rough. It's not sticky. It went the same distance. That didn't happen to us. You could have done what we did, put another one in front of it, and me and Sam was holding it. It went the least furthest on the bubble wrap, and we think it went furthest on the lino because it was smooth, and the bubble wrap was the least we think because it was all bumpy and like the speed bump on the road.
The teacher draws the class together to check how far they now understand the effects of different variables.
Who can tell me something they've learned today? Something they found out today? Darcy?
I was pretty amazed because the blue car went the furthest on the sandpaper.
Do you think that's because it was blue? Or why then? Why do you think it went further on the sandpaper? That's a really important scientific thing that you have to do, is to really tease out why things are happening. You've seen it happen, now why did it happen?
I think it's maybe because the slope on the level was high.
You think because of the height of the ramp. So did you change the height of the ramp? So would that be the reason? If you didn't change the height of the ramp, would it be because of the height of the ramp in that particular case on the lino? What do you think? If you didn't change it, would that be the reason?
We didn't change it though.
So what's the reason more likely to be? If it's not going to be the ramp, what did you change?
The sort of materials on the floor.
The surface. So if you didn't change the ramp and you didn't change the car, could it have been because of the surface?
Ours went furthest on the lino because we think it was smooth than all the others. Yeah. I thought it was going to go quite far on the sandpaper and it went up to the green box. If you use two cars, it won't be a fair test because the wheels could be all worn out and you won't be able to measure it properly because you're going to measure two cars instead of one.
So there could be a difference in the cars.